Here we go. We are ready. Okay, this is going to be... This is on the topic of slope fields. And this is like seemingly one of the most intimidating things that we learn because you look at this picture and you're like, wait, what? What just happened? It's not bad. Okay, these are pretty cool. Gracie asked me this morning, she said, I was going to school. She said, what are you learning today? What letter? And I said, S. And she said, oh, for snake and snail. And I said, and slope fields. And she ran back in the house and was like, okay, cool. Mom's teaching slope fields today. So here we are. Slope fields. They're not bad. It says, consider the graph of f of x shown above. Y'all see it? Sketch small segments of lines tangent to the graph of f at several values of x. So we're just going to go in on this little picture here and draw some tangent lines. I know that at this extreme or maximum, tangent line would be 0. I know here my tangent line would be negative and another 0 and some positives along the way. Okay, so these are just different points, different tangent lines at different points on this curve. This is the concept behind slope fields. If we only have a glimpse of the slopes for a function, we can understand how the function behaves, and even sketch a picture of a solution curve to a differential equation. A slope field is a graph of the slopes for a given function at various points. Generally, we will be given a differential equation and asked to do one of two things. Either we'll have to sketch the slope field at various indicated points, or we'll sketch a solution curve through a slope field. Okay, so you get two different jobs to do with these kinds of questions on the AP exam. I have also seen multiple choice questions where they give you 4 different differential equations for your answer choices, and your job is to pick which one would give you the resulting slope field. Okay. So when sketching a slope field, if given a differential equation, we can sketch a slope field at any indicated points by substituting in the x and y values into the differential equation. AP exam tip: slopes on a slope field will never be undefined. We don't draw those. We don't ever draw the vertical lines. They'll just skip. They will not draw a vertical line segment. Okay, they'll just leave a gap there. Okay, so let's practice. It says, consider the differential equation dy dx equals 2y over x. So this is the slope. Dy dx, that's the differential equation. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. Bless you. So I say let's start at -1, 1. I'm talking about this point right here. -1, 1. We're going to plug in the x and y values into the slope and see what the slope of the tangent line would be at the point -1, 1. Can you understand what we're doing here? So dy dx is 2y over x. So I'm going to have 2 times 1 over -1. In other words, -2. Now, to grade these kinds of questions on the AP exam, they don't get out their ruler and line it up and try to see exactly how precise you are, okay? So at the point -1, 1, we need a slope that is -2-ish. Should be negative, should look kind of steep. Cool beans? What happens when x equals 0? In our equation, our differential equation, what happens when x is 0? It's undefined. So we won't have any slopes on the y-axis. None. We'll just skip all of those points. So let's slide over to +1, 1. If we plug in this point, we get 2 times 1 over +1, which would be +2. So to sketch this slope, we're going to do the same thing, but positive. Draw a little line segment there. Positive. Okay. Slide out to -1 comma 0. We're going to have 2 times 0 over -1 or 0. So at this point, we have a horizontal line segment. The exact same thing is going to happen on the right side because we're plugging in 0 for y. So what do you think that's going to look like on every single value on the x-axis? Straight line, horizontal line, because at every single value there, you're plugging in 0 for y. So if you zoomed out on this slope field, you would see horizontal line segments all the way across. Okay, let's slide down to -1 comma -1. So we're going to have 2 times -1 over -1, which is going to make a +2. So this one should match kind of at the same angle as the +2 one that you had in quadrant 1. And what do you bet happens down here at the bottom at 1 comma -1? Right, -2. So, pretty good. This is a typical AP question. You have to draw the slope field. Okay. Given a differential equation. So how do you do that? You substitute the points into the equation and you figure out what the slope would be there and you sketch it. Okay. We can walk through a couple of these points, but I don't want to do all 10. That's going to take a very long time. Okay. So just getting a couple of these down. Let's do, what is the slope going to look like? Well, along the x-axis, you can tell if I plug in 0 for y, it's going to zero out this Diffie Q. So we're going to have horizontal lines on the x-axis. Would you agree with that? Let's plug in, let's go 2 comma 2. 2 comma 2. So I'm talking about this point up here. If we go 2 squared over 2 minus 1, that's going to be 4 divided by 1, which is +4. That's going to be pretty steepish. Right? Pretty steepish. I'm going to slant mine up quite a bit. And then let's plug in 2 comma 1. Stay positive here. 2 comma +1. We'll have 1 squared over 2 minus 1, which is 1 over 1. Would you agree with that? Still positive, but not nearly as steep. That's how they're going to grade it. They're going to look at it and they're going to say, was this kid pretty steep on 4, but less steep on 1, but still positive? Cool. Do we need to go through the other, 19 points? No, we're good? Okay, let's go on to example 3. It says, while the slope field from example 2 is drawn at only 10 points, it's defined at every point in the xy plane for which x is not equal to 1. Describe all the points in the xy plane, x not equal to 1, for which dy dx is equal to -1. This is very similar to the problems that you saw on the worksheet the other day. This is a shout out to Becca. These were questions that were asked of you on the first homework assignment that I gave you from these packets. This is actually that page. This is example 6. And they had you describe all the points in the xy plane for which dy dx equals -1. And so the way you do that is you take the equation, dy dx, so x plus 2 over 2y, and you set it equal to -1. And then you solve for all of the values for which that occurs. So the way that would work is I would multiply both sides by 2y, right? And I would have x plus 2 equals -2y, and we're going to solve for x. So y equals -1/2 x minus 1. This is an equation of a line that cuts through the slope field, and on this line, all of the slopes are -1, except for at the point where y equals 0. Well, what's that point called? Add 1 to both sides. 1 is equal to -½ x, so we multiply by -2. -2 is x. So except at the point 0, -2, all of the slopes on this line would equal -1. Okay? That's what you're finding when you're doing this kind of problem. And you have to account for the place where they say it doesn't exist, y equals 0. Because why? On this particular differential equation, if y is 0, what happens to the denominator? Bad. It's undefined. So you're not going to have a slope there. Okay? Look at this picture. I'm going to talk to you about these in just a minute. So what we just found was all of the values where the slope was -1. If you were going to find all of the slopes to be +1, wouldn't you say that happens right in this area along this linear equation like this? Can you tell that those are all trending up at +1? That's what you're finding. So you're saying, what's the equation where all of the slopes equal this particular number? And that line runs through those slopes that are slanted in that direction. Can you see kind of what's happening? Can you visualize it? Because I want to go back and solve this question now. It says, describe all the points, x not equal to 1, because we knew that when x equaled 1, we were undefined. That's why we didn't plot any points in this area. So describe all the points for which the slope is -1. So we're going to set the slope, which was y squared over x minus 1, equal to -1. And when we do that, we're going to solve for y. So y squared equals -x plus 1, square root, y equals plus or minus the square root of -x plus 1, except where x equals -1. So if you were to graph this line or this function in the slope field, all of the slopes around that function would have a slope of -1. If you were to plot this particular function in the slope field of all of the slopes in the xy plane, right? So all of the slopes, that would mean like you were seeing the slope field lines for all of these. These are positive, this is negative, this is negativer. If you were to plot this function in this field, all of the slopes where this function is bound have a slope of -1. Right, so except at the place where x equals -1, so you're going to skip those. But if you plot all the other points around that, within this slope field, all of the slopes around that function have the equation -1, or are set at slope equals -1. Okay? Yeah? Does that help you understand at least what you're finding? I don't know. Let's keep going. Okay, when we're sketching solution fields or solution curves, these are some really, really important tips to know. One, the solution curve must be a function. That means you would only be able to sketch the top half or the bottom half of the equation in example 3. This means that it must pass the vertical line test. The solution curve must be continuous. If there's a vertical asymptote or other undefined value, our solution curve will stop. The solution curve must pass through the indicated point. When possible, the solution curves should extend to the end of the slope field, but don't use arrows. Okay, so when they're grading these on the AP exam, These are so easy to get points for, except kids miss them all the time because they don't graph them right. They don't do what they say. Okay, so let's turn over to the next page, and we'll practice sketching a couple of slope fields, or a couple of solution curves. Okay, so this is the slope field of the differential equation dy dx equals cosine y. Everybody seeing that? Okay. Sketch the solution curves through the points 2, 3, and 0, 0. So what they're saying here is, if the solution to the differential equation, so the real function, if the real function had to go through the point 2, 3, what would it have looked like? It has to go through 2, 3, and it's very hard to see here, but I think that 3 is halfway through 3 and 4. So do y'all see this point up here? And it says, they say, draw your points very boldly, so the graders can tell exactly which point you're trying to go through. So now we're going to draw a curve that's bound by these solutions, or by these slopes. Are you following? So if I was going to draw a curve through this point, see how it would go kind of down in this area? And then it would reach this horizontal asymptote and it would go to the end? So you're basically following the shape carved out by the slopes. Don't cross the horizontal asymptote and go to the end of the picture. If you stop a dash mark short, so say I did this, this would receive no points. But if you do it right, you get all the points. So you have to go to the end of the last dash. And then we're going to go up through here until they kind of level off again. Can you see how we're following the path cut out by the slopes? So this slope field, dy dx, represents the slopes of the tangent lines to this curve. And this curve goes through 2, 3. But what if that wasn't the solution curve? We know that an antiderivative would work for any given function, right, within a field. So you have to think of that as well here. This slope curve or slope field could represent a number of curves. Let's draw the curve that might go through 0, 0 and see what that one would look like. So this is sketching the solution curve. I think it's going to come up here and then ride right under that horizontal asymptote. Can you see it? You can cross these slope lines. You're not going to get any points deducted for that, but don't cross the asymptotes. Make sure that you're making your points bold. Okay. You ready for example 5? So for example 5, give me just a second. I believe it says sketch the solution curve through the point 0, 2. So that's going to be, that's not what your picture looks like at all. There we are. This one? 0, 2, and 3, -2. So 0, 2, I'm going to put a big dot at 0, 2, and we're going to sketch this curve that goes through here. Huh? Over 0 up to. I lied. What did I do? I'm looking at two different pictures. Wait, what? How about this? Is this better?
Yes, much better.
Sorry.
No, thank you.
I just thought I completely
Don't know how to
how to
use
do
that.
that anymore. Yeah.
I've forgotten how to do coordinate grids.
Everything I've learned.
Yeah.
Okay, so then this one goes through 1, 2, 3, comma, -2, which is going to be down in this area. And this is contradictory to me, so I want to hold on for just a second until I have just one chance to look at this. Yeah. Okay, so it says the solution curve must be a function. And in my mind, this one doesn't pass the vertical line test. So I would say that we should take off this top half. If we've got to go through the 0.3 comma -2, then we need the bottom half. But your tips say that it's got to be a solution. It's got to be a function. Okay? And the reason I bring that up is because in your homework, you have a question. This is number 6 in your homework. Number 1 in your homework. This is at the top of, I don't know, like the 4th page in your homework. It's the first one of the slope fields. And I went ahead and included it in the lesson so that we could get it right. It says a portion of the slope field of the differential equation dy dx equals cosine x over y minus 1 is shown below. Do y'all see that one? Cosine x over y minus 1. Sketch the solution curve through the point 1, comma 0. And y can't be 1. So if y is not 1, then we're bounded on the top half, right? We've got a boundary in here. Y cannot equal 1. And so we're going through 1, comma 0. That's going to be this point way over here. And which half of this piece of information do we need? Well, we need the bottom half because we can't go across that y can't be 1 asymptote. And if we go that far, it won't be a function anymore. So we're looking at this portion of this curve. Y not equal to 1 would be that horizontal asymptote. This solution is only a function where y is less than 1. Is that making sense? Okay. Yeah. Do y'all want to do the other one? This one? Okay. Here's what I would ask you. This is kind of one of those type questions. This is not hard. This is the same thing. It says sketch the solution curve through the point 2, 0. But before you get all drawing on this one, can you say that they could have asked you, name the equation where the dy dx is 2? Find the equation for the line where all of the slopes are 2, and your equation's probably going to be some linear function that runs right here. And I know that because if I look at the shapes of these slopes, they're all in the positive 2 direction, positive up. Can you see that? So that would be a line where all of the slopes on that line have the same same direction. Okay, draw it. Solution curve through here. And kind of goes up. It's pretty steep. These seem like pretty easy points to get, but they're also pretty easy points to lose. Would you like to work one more of these questions from the first packet, or do y'all think we understand what's happening on these? You understand? All right, so there are a ton of questions in the practice packet that goes with this set of notes. A ton. Spend some time here. You don't have to do all of it. Okay, again, nothing in this class homework-wise has been graded. But I would do enough that you understand exactly what's happening. Okay, feel free to check my solutions later if you get to a place where you want to do that. Use your time today and tomorrow to catch up on the first unit that we did, or first section we did in this unit, and on this one. Okay? We'll do the last part of it Wednesday. Okay. Go team.